What comes to your mind when you hear the word cancer? Probably you're thinking about a constellation, a zodiac sign, or a disease. But what do all these three things have in common? The word cancer comes from the Greek karkinos, that means crab. The disease received its name thanks to the observation of Hippocrates in the ancient Greece of some big tumors with veins that resemble the legs of the animal. But why are tumors formed in the first place? All the cells of your body grow, acquire a specific function, divide, and eventually they die. The cells have a lot of proteins that regulate these processes, but what happens when some of these proteins are mutated? Some mutations can cause your cells to grow and divide without control, forming tumors. One of the most important types of cancer is colorectal cancer, which is the third most common type of cancer worldwide and the second leading cause of cancer deaths according to the World Health Organization. KRAS is one of the most important proteins in colorectal cancer because it's mutated in 45% of the cases. But all the efforts to design drugs that specifically target KRAS have been mainly unsuccessful. Nevertheless, KRAS activity relies on small changes in the protein such as phosphorylation. Phosphorylation adds only 5 atoms into the protein, but these 5 atoms can change the behaviors of the cells completely. We have studied how phosphorylation of KRAS can modify cancer properties. We compare colorectal cancer cells that can phosphorylate KRAS with colorectal cancer cells that have a mutation and cannot phosphorylate KRAS. We analyze the secretome composition, the proteins that are secreted, released into the medium, and we observe that in phosphorylatable cancer cells, there are more proteins secreted related with cell motility and invasion compared to the non-phosphorylatable cancer cells. Among these proteins, we have cathepsin B, which is a protein that degrades the extracellular matrix, allowing the cells to move and to produce metastases. That's the reason why we decided to inject these cells into the spleen of mice and to analyze the liver metastases. And we observed that there were a lot more metastases in the liver of phosphorylatable KRAS cancer cells than non-phosphorylatable ones, proving that KRAS phosphorylation directly regulates metastases. Can you imagine all the possibilities with this information? Only 5 atoms to control cancer. Only change 5 atoms to kill this fatal crab. Thank you very much for your attention.